Hello everyone, my name is Nyamungu Salome Marion and I would like to welcome everyone to my YouTube channel. Please like and subscribe and share with any other person who is interested in getting to know more about language libraries and threaded parallel programming in computer science. So my channel will help in highlighting more IT related content in case you need to know more about it. So I'll take you through language libraries and threaded parallel programming. So we should first get to know what language libraries are. Language libraries are tools or collection of codes that provide pre-written functions and modules to perform specific tasks or solve particular problems. So with this, we get to know that these language libraries, I will give it in an example of an already written book in a library. In case you need to use that book, you just go to the library, get it, you use it, read it, take it back. And in case you need to refer to it, you would use it. So these are the codes. They are already pre-written by some other programmer, and in case you need a certain function within your code, you just use this pre-written codes, put it into your programming code, and it will help you do a specific function without having to write this code. So they help to optimize programming tasks. For example, if you are making programming mobile apps or softwares, you can utilize language libraries, and they provide reusable functions, clauses, and resources which help in performing common programming tasks without needing to write new codes from scratch. They are crucial for improving productivity and ensuring code quality and leveraging existing well-texted solutions. So since they're already existing and they are well written, so why not utilize them without you having to write a code which you later have to debug, and it might not even do the function you want, but these libraries are already there at a time freely or even at a cost, but cost friendly, and since you need them. And now, in this context of parallel computing and threaded programming, language libraries offer APIs, and APIs are application packet interfaces and utilities to simplify the development of parallel applications. So in each programming, in any programming packet, let me say, anything you need that you're programming, either code, a software, mobile app, you will need APIs. So these language libraries also provide APIs. So key characteristics of language libraries, I had already talked of this one. They are already pre-written. They were already written by a certain programmer. So language libraries consist of pre-written codes that developers can use in their applications. They're already pre-written, they're already existing, and they are well tested. So why not use these pre-written codes? So they have reusable functions and clauses. You can reuse the same language library or the same code in another code without, since they are performing a specific task, you can reuse them, so they have that reusability function. So and then the modular language libraries often modular, allowing developers to use only the part they need. So you can have a language library and you only get the part you need, a specific function. It can be a full code, but for instance, you just need, I'll give it in an aspect of, you're making an AI app and you just need something that can help detect motion. You can use the ModPipe face API. That will just help you get to just the part of detecting facial features. Then they are language specific. With these language libraries, each language library is specific to a certain programming language. For example, we have very many different programming languages. We have C++, we have Java, we have Python, very many. So each of these languages has their own language, their own libraries are used, and the libraries are usually specific to that programming language, but sometimes can be used across multiple languages with bindings. So let's see the benefits of using libraries. They are time saving. Since I already said, you don't need to write a full code from scratch. Just use a language library, and it will help you do that particular code without you having to go through the stress of writing a new code. So they're reliable and testing. Language libraries are often well tested and maintained, reducing the likelihood of bugs since they're already written and they are secure and they are tested. So that makes them a language library because they are tested that they can make a specific function. So, and they also focus on core functionality. Each language library has to be able to do a certain function. If that code can't do anything, then it's not a language library. Developers can focus on the unique aspects of their applications rather than reinventing the whole wheel over common tasks. Then, community support. Popular language libraries often have extensible document tutorials and community support. So now we have types of language libraries. We have the standard libraries, and they're included within the language, like the programming language, since they are standard. So within that programming language, you may find some particular libraries which already, and they provide basic functionalities such as input-output operations, string manipulation, data structures, and more. For example, in the Python language, we have math module. In the high-level programming language template, we have standard template libraries. So those are standard libraries we have there. So another type, we have the third-party libraries. These ones are created by third-party developers or organizations. So they often address more specialized needs. So by the time they're already made, so they are more advanced compared to the standard, and they are specialized, like machine learning, using API to teach a machine what to do, web development, data analysis, etc. So an example, we have NumPy. So that one is a library for Python, and Boost for high-level language, so or C++. So, and in other common libraries we have. So now here are the common libraries in the popular programming language. So I had already said the popular programming language, we have Python, JavaScript, and others. So for Python or JavaScript, for Python, so we have NumPy. I already talked about it before in the previous slide. So this is for numeric operations. Then we have Pandas. It is used for data manipulation and analysis. We have request. This is used in hypertext transfer protocol requests. So in case you are sending a request, you have to use request. Then TensorFlow, it's used in machine learning to teach a machine what to do. If you are teaching a model, so you can use a language library of TensorFlow. So in the JavaScript language, we have React. So with React, you can use it for building user interfaces. We have Lodash, it's used for utility functions. We have Express, which is used for web frameworks for Node.js or Node JavaScript. So, and in Java, we have Spring Framework. It's used in enterprise application development. And we have Hibernate, that is a language library, and it's used in object relational mapping. We have Apache Commons utility classes, and we have Ruby, we have C++, sorry, and C++ has language libraries like Boost, Open, Computer Vision, Qt. So with the Boost, it's used in a wide range of utilities and enhancements, and with Open Computer Vision, it's used in computer vision. Then Qt, it's a cross-platform graphic user interface development library. Then with Ruby, this is a programming language. It has Rails, which is also used in web development. It has Sinatra, which is used in lightweight web frameworks. It has RS spec, it's used in testing frameworks. So it just tests, instead of you having to pass through how do I test, you just have to use RS spec. So, and then we have R. R is also a programming language, and this programming language is used for statistical computing and data visualization. So one of the libraries we have is ggplots2. So it's used in data visualization. Then dplyr R, it's used in data manipulation. Then caret, it is used in machine learning. So how are libraries used? I've said a lot. So how are they used? How are those functions used? So one of the uses we have importing. So with this, libraries are typically imported into a program using import statements. So these import statements, in some libraries are even used to import other libraries. So libraries can be used to import new things within our code. So I'll give you an example. With Python, we use import numpy as np. So you're importing numpy. And in JavaScript, Node.js, we have consist express equals to require in brackets express. So you get to know that with that, they are saying that. Then in Java, we have import Java util array list. So we are importing an array list. Though then also another one, they are used in installations. So these libraries can also be used in installation. So the third-party libraries often, which I already talked about, the types, and I said we have a type of third-party libraries which are more advanced compared to the standard libraries, and they often need to be installed using package managers. So we get to know that these third-party libraries often need to be installed. So with this, we shall use a certain library. So to import, so we need to install that library. And with Python, we say pip install numpy. So we have installed numpy. Then in JavaScript, we have npm install express. So we have installed express. So and then in Java we have Maven or Gradle dependencies. Then another way to use libraries is by calling functions or methods. By calling functions or methods. Once imported, developers can call the function, methods or classes provided by the library. So you have to first. So after that, the libraries are also used to call functions and methods. This can be a recursive call. It's different ways of calling functions. So in Python, we have np array. So we are calling an array of 1, 2, 3, and in JavaScript we have app equals to express. Then in Java we have array list in string list. So we are calling a new array list from the string of list. Then we have threaded parallel programming. So I'm just telling you what language libraries are, and now I'm telling you what threaded parallel programming is. So threaded parallel programming involves developing a programming task into smaller parts that can be executed concurrently by multiple threads. So we have a specific task, but then with that task I'll give an example of having multiple processors. So we shall give those different tasks to different processors. Like we shall break the tasks. Then we give one part of the task to one processor, another part of the task to another, and to another. So that all those will be processed within a shorter time and at the same time. But that's how we have broken it into different parts, but it has been processed and optimized in a shorter time. So that's what I can simply explain to you as threading. So threads are independent sequences of instructions that can run simultaneously, like I said, either on a separate CPU core or on different processing units like GPUs, and GPUs are graphic processing units. So Threaded programming is a powerful paradigm for exploiting parallelism. So, in software applications, enabling improved performance, resource utilization, and responsiveness. So, key aspects of threaded parallel programming. So, a key aspect to find in threaded parallel programming is concurrency. I would say concurrency is like solving something simultaneously. Yeah? So in threaded programming, threaded programming enables concurrent execution of multiple tasks within the same program. This concurrency can improve performance by utilizing available system resources efficiently. So we are simultaneously solving multiple tasks within the same program. That's what I can say concurrency is. Then we have task decomposition. With decomposition, is breaking a big task into smaller units. So the program's tasks are decomposed into smaller units of work that can be executed independently. These tasks are often called threads or executions, where I said threads of executions. So by breaking them, we can either give them to different cores or different processing units, but they will be processed or worked upon in the same time, and like simultaneously. Then we have another aspect is synchronization. So since threads share resources like memory, it's essential to synchronize their access to prevent data corruption or inconsistencies. So synchronization mechanisms like locks, barriers are used to coordinate the execution of threads. Then another aspect, we have communication. Threads may need to communicate with each other to exchange data or coordinate their activities. Regardless, they are threads, but they are of the same task, so they need to still communicate and ensure that they are going to do the same thing within the same task. So inter-thread communication mechanism like message passing and shared memory are used for this purpose. Then another, we have scalability. So threaded parallel computing aims to improve the scalability of applications, allowing them to take advantage of multiple core processors and distributed computing environments. So threading will deal with multiple processors, multiple cores. So that scalability is also part of threading. Now, benefits of threaded parallel. So one of the benefits we have is improved performance. By leveraging multiple threads, parallel programs can execute tasks concurrently, reducing overall execution time and improving throughput. And it also utilizes all the resources and improves performance. The things will process faster and better. And also resource utilization. Threaded programming allows efficient utilization of available system resources such as CPU cores, memory, input-output devices, since each thread will have to utilize them. As serving one thread, so might have 3 threads and they utilize all the available cores or processors. And another one, we have responsiveness. Parallel programs can remain responsive even when performing intensive computation or input-output operations by offloading tasks to separate threads. So the responsiveness is still there. So modularity. Threaded programming promotes modular design by decomposing complex tasks into smaller tasks, more manageable units of work. This makes codes easier to understand, maintain, and debug. And the last one is flexibility. Threaded parallel programming provides flexibility in designing algorithms and applications, allowing developers to exploit parallelism at different levels of granularity. Now, challenges of threaded parallel programming. We have concurrency bugs. So, writing correct concurrent codes is challenging due to issues like race conditions, deadlocks, live locks. These bugs can be hard to reduce and debug. Then synchronization overload. Synchronization mechanism introduces overload and can lead to performance degradation if not judicially, if not worked on. Then load balancing, like remember each thread is its own load, so the more threads, the more load. So ensuring an even distribution of workload among threads can be challenging, especially in dynamic environments where the workload may vary over time. Then the last challenge we have is scalability limits. Some applications may face scalability limits due to factors like contention for shared resources or the overhead of threaded creations and management. Like since the also threads are also affected by the number of cores CPUs. So even if you want to have 3 threads but you have only 2 cores, even if you want to have 6 threads but you only have 2 cores, meaning there will be four virtual processors. Then the others you can't have 6, so they will be limited to 4 cores. Then examples of language libraries used for threaded parallel programming. So now I'll be highlighting the library code, but at first I was just pointing them out, but now let me go more in depth. So the first language library we have is the OpenMP, which is the Open Multiprocessing. So with this, it can be used in C, C++, Fortran, those are the languages, the programming languages this OpenMP can be used in. And OpenMP is an API that supports multiple platform shared memory, multiprocessing programming in C, C++, and Fortran. It provides compiler directives, runtime library routines, and environment variables to enable parallel execution of code segments. And with this, we just get to know that OpenMP is widely used for parallelizing code in those different languages on multi-core processors. So they are key, and we'll see that they provide a set of OpenMP provide a set of compiler directives, runtime library routines, and environment variables that enable shared memory multiprocessing programming. So the features of OpenMP: compiler directives to parallelize loops and regions of codes, runtime library routines for parallelizing programming, environment variables to control the execution of parallel programs. Now this is an example code of OpenMP library or API. So this code is written in C, in the language C, or computer programming language. So with this code has, we'll see on line 5, we have a string that says pragma omp parallel. So this string creates a team of threads, and each thread executes the code within the blocks. So that's why you see another team of threads. So that one just creates the threads. So another language library we have is Java Concurrency API. So the Java Concurrency API is a set of high-level concurrency utilities and low-level primitives for writing concurrent and parallel programs in Java. It includes classes like thread, executor, and future for creating and managing threads, as well as utilities for synchronization and coordination. So with this, we just know that So, and the key features of Java Concurrency API, we have the executor that is used for managing thread pools, the concurrent collection, like concurrent hash map, you'll see that as an example in the code. Then we have the synchronization utilities, such as the semaphores and locks, then the atomic variables for lock-free thread-safe operations. So the example code we have, so in this we see that we have a string java.util.concurrent, which is on the line Java concurrency. We see a block or string that says java.util.concurrent, and we shall see this in the code that import java.util.concurrent executor service, and then import java.util.concurrent executor. So we are importing those strings. So with this, the java.util.concurrent executor service, the java.util concurrent provides a rich set of classes for building multi-threaded applications. And now when we import java.util.concurrent executor service, it's to manage a pool of threads. Then the import java.util concurrent executor does the same to manage a pool of threads and execute worker thread instances. And another library is we have threading building blocks, TBB. So threading building blocks in C++ level programming template library developed by Intel for parallel programming. It provides higher level constructs for parallelism, such as parallel loops, parallel algorithms, and concurrent data structure, making it easier to write scalable and efficient parallel codes. So it creates scalable parallel applications. That's what you should know with this. Just create scalable parallel applications. So the key features within the threading building blocks, we have the task scheduler, which is used for efficient use of available processing cores. Then we have the parallel algorithms, or the parallel for, the parallel reduce, etc. Then we have concurrent containers, where we see the concurrent vector, concurrent queue, etc. So we have an example code here, and this example code, the code is written in C++, the higher level language programming. And with this code, it demonstrates the use of TBB, the threaded building blocks. With this, we see parallel reduce to some elements to a vector in parallel. So the string I've talked about, we see it on the fourth line of the code, where we say void parallel sum. On the fifth line, where we see int sum equals to TBB parallel reduce in brackets TBB block range size of 0 vector size, which vector size is greater than the range. And the other library we have is the parallel pattern library. So the parallel pattern library is a C++ library developed by Microsoft for parallel programming. It offers higher level constructs. For exchanging parallel algorithms, including parallel loops, parallel algorithms,
e.g. the parallel for each parallel transform and concurrent data structures. So the key features of parallel pattern library, we have the parallel algorithm, where we have the parallel for, parallel evoke, etc. And we also have the task-based parallel model and the concurrent self containers. So the example code we have here, it's also written in C++. So it's a part of so with this, we see in the code we see concurrency parallel reduce, which is used to sum elements of a vector in parallel. And we see that also on line 5, where we see int sum equals to concurrency parallel reduce in bracket vector dot begin vector dot end equals to no comma 0. So there it's used to sum elements a vector in parallel. So we are adding the elements of the vector from the beginning, adding them to the vectors up to the end. Then we have the last library we shall be looking at is the CUDA toolkit. So what is CUDA in full? So CUDA in full is Compute Unified Device Architecture. So the Compute Unified Device Architecture Toolkit is a parallel computing platform and programming model developed by NVIDIA for GPU, which I had already said GPU is the graphic processing unit. And okay, anyone doesn't know what a GPU is, it's a specialized electronic circuit initially designed or developed to accelerate computer graphics and image computing. So the NVIDIA acts for GPU accelerated computing. So it executes it provides APIs. The CUDA toolkit provides APIs and libraries for writing parallel codes that execute on NVIDIA GPUs, including CUDA C, CUDA C++ language extension and runtime APIs. So the CUDA allows developers to use GPU for general purpose processing codes. It also adds 2 arrays on the GPU. So here features of the CUDA, we have the direct access to the GPU, virtual instruction set and memory. Another feature, it has extension to C or C++ that allows parallel computation. And another feature, it's a rich set of libraries, where we see libraries such as CU BLAS, CU FFT, etc. for common operations. So in this we see a code, and with CUDA it adds kernel functions, runs on the GPU, performing element-wise conditions of the array. So you will see add kernel. So with add kernel function runs performing element-wise additions of the array. So it will just keep on adding different elements onto the array, which will add the array size. So now this slide talks about how these different libraries simplify parallel programming tasks and manage threads. So with OpenMP, or the Open Multiprocessing, we shall see one of the ways it simplifies is through simplifying parallel programming. Sorry, I'm having some noise inconvenience, but let me continue. So the OpenMPC simplifies parallel programming. It simplifies parallel programming tasks by providing compiler directives that allow developers to simplify parallel regions and loops without explicitly managing threads. So in the example I gave before of the example code, where we saw PRAGDA, or Parallel Directive, which creates a team of threads to execute loops in parallel without the need for manual thread creation or synchronization. So it will just help to create the threads for you. Then we see it also helps in managing threads, because after creating these threads for you, it also helps in managing these threads. So it automatically manages the creation, scheduling, synchronization of threads, making it easier for developers to write parallel codes. The library handles thread creation, workload distribution, and reduces operations in this case. The reduction clause to contribute to combine local results into a single global result. So let's also see how Java Concurrency API simplifies parallel programming. So it simplifies parallel programming through providing high-level concurrency utilities and abstractions such as the executor, service, and future, which abstract away the complexities of thread management. In the example code I gave above, the executor service and submit method handle the creation and execution of tasks asynchronously, allowing the main thread to continue its computation without blocking. Then another way it manages these threads through thread pools, allowing developers to reuse the thread and avoid the overhead of creating and destroying threads frequently. The thread pool, where we see a string which is new fixed thread pool in brackets number threads close bracket. It manages a fixed number of threads and tasks are assigned to available threads for execution. And then we see the threading building block. This one simplifies parallel programming by providing high-level constructs like parallel reduce, which abstract away the detail of thread creation and synchronization. In the example code, the parallel reduce function automatically divides the workload into smaller ranges and executes the reduce operation in parallel across multiple threads. And it manages threads through intentionally abstracting away the low-level details of thread creation and management. Developers only need to specify the parallel computation and the reduction operation. The threaded building block takes care of dividing the work, scheduling threads, and combining results efficiently. Then, best practices for writing efficient threaded parallel codes using language libraries. So what are the best practices someone has to follow in order to write the efficient parallel or threaded parallel codes using language libraries? So one of the best practices is first understand the problem and the algorithm. Before parallelizing code, ensure a thorough understanding of the problem and algorithm. Not all problems benefit from parallelism, so it's essential to identify parallelizable sections of a code where significant performance gains can be achieved. And another is choose the right library and framework. Since each library, I had said before, does a specific function, make sure before you choose that library, is it doing what you want it to do? If not, then don't use it. Seek for a better library which will satisfy your problem. So select a library or framework that best fits the requirements of an application and the underlying hardware architecture. Consider factors such as ease of use, scalability, and support of specific parallel programming paradigms. And then divide workload evenly. or load balancing. Ensure load balancing. So divide the workload evenly among threads or processors to ensure efficient utilization of resources or optimization. Load balancing prevents such threads from being idle while others are overloaded, thereby maximizing overall throughput. Then minimize synchronization overhead. We had seen that synchronization overhead is one of the problems that face threading. So reducing synchronization overhead by minimizing the use of locks, multi-X's, and other synchronization primitives. Excessive synchronization can lead to contention and serialization, negating the benefits of parallelism. Prefer lock-free algorithms or use fine-grained locking strategies where necessary. So, use data locality or cache awareness. Exploit data locality and cache awareness to improve performance. Accessing data that is closer in memory and leveraging cache coherence can significantly reduce memory access latency and enhance overall throughput. Consider data partitioning and data-oriented design principles to maximize cache efficiency. Then another one is optimize communication and data transfer. So minimize communication overhead between thread or processors by reducing unnecessary data transfer and synchronization. So we are optimizing, we are making use of the available resources, we are minimizing the wastage, yeah? and ensuring proper usage. So with this, reducing unnecessary data transfer, use asynchronous communication and non-blocking operation where possible to overlap computation with communication and hide latency. Then another is profile and benchmark performance. Like profile and benchmark performance. Like I'll give this in an aspect of taking reports. So the profile the parallel code to identify performance bottlenecks and areas for optimization. Use profiling tools to measure execution time, CPU usage, memory usage, and other relevant metrics. So benchmark different parallelization strategies and configuration to determine the most efficient solution. So I was telling us to take note of the different profiles and benchmark the performances, like take reports. Then scalable responsive. So another is scale responsively and dynamically. So design parallel codes to scale responsively with the available hardware resources and workload characteristics. Use dynamic load balancing techniques to adapt to changes in workload distribution and system conditions, ensuring optimal performance across variable conditions. Like that, don't use static load balancing. It will be static, it won't even balance the load. So another, optimize for specific hardware architecture. When we are coding or when you make a software, you have different hardware capabilities. You might put it on a computer which does not have a microphone. You might put it on a computer which has no access to a camera. So we have to optimize for specific hardware architectures because each hardware can be of a different architecture. So consider optimizing parallel codes for specific hardware architectures such as multi-core CPUs, GPUs, or distributed systems. Utilize platform-specific features, instruction sets, and hardware accelerators to exploit parallelism efficiently and achieve maximum performance. Then lastly, regularly review and refactor code. Like
It's even called maintenance. Ensure you're maintaining it. Even after developing a code, even after developing a software, you ensure maintenance. Is it still working as wanted? Is it working as before? Has it declined? Like, ensure you're regularly reviewing and refactoring code. Continuously review and refactor parallel code to improve clarity, maintainability, and performance. Document parallelization strategies, rationale behind design, decisions, and others. etc. So that is the end for now. Thank you for listening. Thank you for coming through. I remain Marion, and I was the presenter for today, and we dealt with the language libraries and threaded parallel programming. So we are done with this, and in case of any comments, any questions, please feel free to comment down below in the comment section, and I will reply when I get to see your comment. Thank you and have a blessed day.